Good morning, students. Welcome to Computer Aided Design course code P20DE102. I am Rakesh, Assistant Professor in Department of Mechanical Engineering, Kids Warangal. Week 3 course discussion topic on Bezier curves. Before going to enter this topic, let us see the lecture outcome for this topic. After completion of this lecture, student will be able to determine the parametric equation of Bezier curve. Okay, coming to this topic, Bezier curves and surfaces are introduced by P. Bezier of the French automobile company of Renault in the year of 1962. He used this type of curves and surfaces in his software. The software name is Unisurface. Unisurface, which has been used by designers to define the outer panel of several Renault car bodies. These curves known as Bezier curves. Let us see the one sample curve of Bezier curve. You can see here, this is the sample Bezier curve. The Bezier curve is defined in terms of location of n plus 1 control points. These points are called as data or control points. You can see here, here P0, P1, P2, P3 are control points, are also called as vertices. Here characteristic polygon is represented with a dashed line. The Bezier characteristic polygon, which uniquely define the curve shape. Only the first here the first point is P0 and the last point is P3. The first and the last control points are vertices of the polygon actually lie on the curve. The other vertices define the order. Other vertices means P1, P2 define the order and derivatives and shape of the curve. Here P0 and P3 are first and last point of that Bezier curve. Remaining points are control points or vertices define the order, derivatives and shape. With the help of P1, P2 we can change the curve shape. It is the example for approximation curve. Bezier curve and B-spline curves are called as approximation curves because here the given all points does not pass through the curve. For example, I am taking few points 1, 2, 3, 4, 5. The curve must and should pass through the first and last point. Remaining points are approximate near to that curve. So that's why these curves are called as approximation curves. Example is Bezier curves and B-spline curves. Mathematically, for n plus 1 control points, the Bezier curve is defined by the following polynomial equation. Polynomial uh, polynomial equation, that is P of u equal to summation I equal to 0 to n Pi Bi comma n of u. The limits are 0 less than or equal to u less than or equal to 1. Here n is the segments, that means each polygon. You can see here in the figure the number of segments are this is the one segment, this second two, this is three. These the given figure having three segments, and n plus 1 control points, that means p0, p1, p2, p3, so four control points. The u lies in between 0 and 1. uh, where P of u is any point on the curve, and Pi is a control point, Bi comma n are the Bernstein polynomials. That the Bezier curve has a Bernstein basis. The Bernstein polynomial serves as the blending or Bézier function. Now we can write as b comma b suffix I comma n of u equal to c of n comma I u power I into 1 minus u power n minus I. This is the Bernstein basis function, blending or basis function, where c of n comma I is the binomial coefficient. Let us see the formula for Bernstein polynomial. Bi comma n of u equal to n factorial by I factorial into n minus I factorial into u power I into 1 minus u power n minus I. Here c of n comma I equal to n factorial by I factorial into n minus I. This is the c of n comma I. This is the polynomial coefficient. uh, Now let us write the Bezier curve for three terms. Then that means n equal to 3. Cubic Bezier curve. That means I equal to 0 to I equal to 0 to 3. Now elaborate the previous equation. P of u equal to p naught b 0 comma 3 of u plus p1 b 1 comma 3 of u plus p2 b 2 comma 3 of u plus p3 b 3 comma 3 of u. Here bi comma n of u is a function of the number of curve segments. This is the equation with respect to parameter u. Now calculate Bernstein function, that is b 0 comma 3 of u, b 1 comma 3 of u, b 2 comma 3 of u, b 3 comma 3 of u. Already we know that formula. Bi comma n equal to bi comma n equal to n factorial by I factorial into n minus I factorial into u power I into 1 minus u power n minus I. Now construct one table. I, we know the form b I comma n formula is n factorial by I factorial into n minus I factorial. The limits from 0 to 3, 0, 1, 2, next 3. Now let us take I equals 0, I equals 0 and n equal to 3. Here n is number of control points 3. 3 factorial. 3 factorial by I factorial means 0 factorial into n minus I. N means 3, I equal to 3. So 3 minus 0, 3 factorial. So 3 factorial by 3 factorial equal to 1. Next I equal to 1, n equal to 3. 3 factorial by 1 factorial into 3 minus 1, that means 2 factorial. 3 factorial by 2 factorial. Here 3 factorial equal to 3 into 2 factorial. 2 factorial, 2 factorial get cancelled. The answer is 3. Next one, n equal to 3 factorial by I is 2 factorial. 3 minus 1. 3 minus 2. That means 1 factorial. So the answer is 3. 3 into 2 factorial, 2 factorial get cancelled, 3. The last one is I equal to 3 and n equal to 3. 3 factorial by I means 3 factorial, n minus 3, 3 minus 3, 0 factorial. So 3 factorial, 3 factorial get cancelled, the answer is 1. Now let us substitute these values in this equation. So let us write b of b0 comma 3 of u equal to this value is for I 1, u of 0 into 1 minus u power 3 minus 0, that is 3. So the answer is 1 minus u cube. The next one is b of 1 comma 3. Here b of b0 comma 3 of u equal to 1 minus u whole cube. The second one is b1 comma 3. b1 comma 3 of u equal to n factorial by I factorial into n minus I factorial, that value is 3. 3 into u power 1 into 1 minus u power n minus I, 3 minus 1, 2. So the answer is 3u into 1 minus u square, 1 minus u whole square. The next one is b suffix 2 comma 3 of u. b suffix 2 comma 3 of u. b2 comma 3 equal to n factorial, that means 3 factorial by 2 factorial into 3 minus 2 factorial, that value is 3. 3 u power I means 2, 1 minus u whole to the power of n minus I, 3 minus 2, that is 1, equal to 3 3u square into 1 minus u. The last one is b3 comma 3 of u. b3 comma 3 of u equal to that value is 1, that means n factorial by I factorial into n minus I factorial equal to 1. 1 u power I is 3 into 1 minus u power 3 minus 3, that means 0. So the answer is u cube. Now let us substitute these values in the equation 2. In this equation, I think this is the equation number 3. P of u equal to P naught, B 0 comma 3 of u equal to 1 minus u cube into 1 minus u whole cube plus P1 into B1 comma 3 of u, that value is 3u into 1 minus u whole square, 3u into 1 minus u whole square plus P2 into B2 comma 3, that is 3u square into 1 minus u. The last one is B3 into B3 comma 3, that is u cube, P3 u cube. This is the equation in terms of parameter u. We can write in the scalar component, that is P of ux in the x direction, that is P Px naught into 1 minus u whole cube plus Px1 into 3u into 1 minus u whole square plus Px2 3u square into 1 minus u plus Px3 u cube. Similarly, in the y direction, P uy equal to P y naught into 1 minus u whole cube plus P y1 3u into 1 minus u whole square plus P y2 3u square into 1 minus u plus P y3 into u cube. In the z direction, P of uz equal to Pz naught 1 minus u cube, 1 minus u whole cube plus Pz1 into 3u into 1 minus u whole square plus Pz2 3u square into 1 minus u plus Pz3 into u cube. These are the formulas in the scalar component x direction, y direction and z direction. Now let us see the now this is the equation for general cubic Bezier curve. Let us determine the tangent curves for first point and last point. For calculating tangent curve, we need to differentiate the above equation. That is p dash of u. Uh, First write p of u equal to, the formula is p naught 1 minus u whole cube plus p1 3u into 1 minus u whole square plus p2 3u square into 1 minus mu plus p3 u cube. Now simplify this equation. P of u equal to p naught u whole cube equal to plus here only one term u is there, so that's why I'm not simplifying this term. Now I'm going to simplify the remaining terms, that is p1 3u into 1 minus u whole square, that means a minus b whole square, a square plus b square minus 2ab plus p2 3u square minus 3u square into u minus 3u cube plus p3 u cube p naught into 1 minus u whole cube plus 3u into 1, that means p1 3u plus p1 3u cube minus 3 into 2 6 6p1 u square plus p2 into 3u square, that is p2 3u square minus p2 3u cube plus p3 u cube. Now differentiate this above equation with respect to this parameter, that p dash of u equal to here differentiate derivative of this term 3 p naught u. U derivative is minus 1, so you can put minus before 3 p naught u, minus 3 p naught u plus p1 3u derivative is 1 plus 3 constant u cube derivative is 3 u square, so 9 3 into 3 9 p1 u square. Next 6 to the 12 p1u plus u square derivative 2u, 2 into 3 6, 3 into 2 6 p2u, u cube derivative 3u square, 3 into 3 9, minus 9 p2 u square plus u cube derivative is 3 u square, that means 3 p3 u square. The given Bezier curve starting limit is u equal to 0. Let us take p of 0 equal to, now substitute u equal 0 in this first equation, that means this equation, this is, let us assume this is the a and this is the b. Now substitute u equals 0 in this equation a, 1 minus 0, so p naught, remaining all terms are 0 because here multiplication factor is there, so you can multiply with 0, that value is 0, 3 into 0 0, 0 into something 0 0, so p of 0 equal p naught. The next term is uh, the end point is 1, so substitute u equal to 1 in the same equation. 1 minus 1 0, 1 minus 1 0, 1 minus 1 0, p3 p3, the last term is p3. Now substitute the same limits in the uh, tangent equation, that is p dash of u, p dash of 0 equal to, now substitute u equal 0, this term is 0, u equal to 0, this term 0, this term is 3p1, 3p1, this term 0, this term 0, this term 0, remaining all terms are 0. This is the, I think this is the p3. Another term 3p naught, where is p naught? Actually this is the 0, minus 3p naught, so write minus 3p naught. Let us take common, that is 3 into p1 minus p naught. The next term is p1 of 1. Now substitute 1 in the same equation, we can get 3p1 plus 9p1 minus 12p1 plus 6p2 minus 9p2 plus 3p3. Now simplify this term. Here 3 plus 9, 12p1, 12p1 get cancelled. 6p2 minus 9p2, that is minus 3p2 plus 3p3. Now let us take common as 3. 3 into p3 minus p2. Here one important condition is there, that is we can also write for nth term n into p1 minus p naught. From this equation we can write for nth term, that is 3 into pn minus pn minus 1. Here I have solved for only cubic Bezier curve. If we take more points, it gives a relationship between p dash of 0 equal to n into p1 minus p naught for end point, that means n equal, that u equal to 1, p dash of 1 equal to 3 into pn minus 1. where uh, P1 minus P naught and Pn minus Pn minus 1 define the first and last segments of the curve polygon. Uh, the final conclusion is the order of Bezier curve is a function of the number of control points. For for example, 4 control points, that means n equal to 3, always produce a cubic Bezier curve. You can see the different shapes in this figure. This is the cubic Bezier curve for various control points. Uh, the figure shows that the order of defining control point changes. The polygon definition which changes the resulting curve shape will be changed. The arrow depicts on each curve shows its parametrization of direction. You can see the first figure. Here these are the two control points P1, P2. With the help of these two control points, it gives this shape. In the second figure, with the help of these two control points, it gives this shape. Similar like with the help of these control points, the resulting curve will be occurred in the Bezier curves. This is the brief discussion about determine the parametric equation of Bezier curve. Having completed the discussion on Bezier curves, now students should be able to determine the parametric equation of Bezier curve. For more information, the students are required to uh, read the following textbook, that is Ibrahim Jeet and Shiva Subramania R.R.CAD Theory and Practice, second edition, New Delhi, Tata McGraw-Hill, 2010. The reading chapter is 4.6.2. Thank you for watching.